Hi, this is Mrs. Nixon. Welcome to AMI Day 19. This problem is about density. First, let's read the questions. Number 1, using figure 2.1, explain how to read the measurement shown. Let's look at 2.1. Here it is. It's a diagram of a graduated cylinder, and you can see that it has a meniscus. Remember that a meniscus, and I added this to the problem so you could remember the word, is the concave, that means curved in, surface of a liquid in a graduated cylinder. So let's go back to the problem. Explain how to measure the volume of number 1. Using figure 1, explain how to read the measurement shown. I bet you could do that right now without even reading the rest of the passage. Here's your sentence frame. I read the measurement in figure 2.1 by looking at, and it's not just the meniscus. You need to tell us what part of the meniscus do you look at to measure the volume. All right, let's move on to number 2. Using figure 2.2, explain how to measure the volume of an irregularly shaped object using the volume displacement method. Let's take a look over here at figure 2.2. You've got a graduated cylinder filled with water to 20 milliliters. And then look what they've done here and what happened to the water. You need to do the math to decide what the volume of this rock is. And that's basically the water displacement method here. So here is your sentence frame for that one. In order to measure the volume of an irregularly shaped object during volume displacement, first I do this, then I do that. Don't forget to put the math part in there too. So tell the steps by looking at the diagram. There are steps shown right there. Describe those steps, and then what kind of math would you use to figure out what the volume is of that rock? All right, let's look at number 3. Number 3 says, using figure 2.2, 2.2, determine the volume of a 7-gram lump of aluminum and calculate the density of the aluminum. So what you're going to do now is you're going to use those steps that you just told us about up here, and you already have your mass, okay? So now you're just going to find out what its volume is by following your steps and doing the math. Here is your sentence frame. It says, based on figure 2.2, the density of a 7.0 lump of aluminum is blank because blank. So you'll find the volume. Once you find the volume, you can plug it into the formula here. Density equals mass divided by volume. Remember that you've already been given the mass, and you can find the volume using this method, and once you do the math, you'll get the density. Let's go ahead and read the passage and see if it gives us any more information. We probably honestly could do it without the passage as it stands, but let's go ahead and read it anyway. Density is a measurement that comes from mass and volume. It describes the amount of matter in a given amount of space. Density is a physical property of elements that never changes for a specific element. This unique physical property allows scientists to identify unknown elements by their calculated density. Density is mass divided by volume. There's your formula. D equals m divided by v. The figures give display readings from graduated cylinders. Answer the following questions below using the figures to assist you. So there you have it. If you have any questions, be sure to email any one of us science teachers and we can help you. Thank you. Have a good day.